Alright, well, welcome to physics. Now here we go. Let's try doing this first one here. Let's see. So for number 1 and 2, we have is a person walks 6 meters west, then turns around and walks 4 meters east. So let's just take a look at what that means. Okay, so I'm going to use the graph paper on the back of the homework, and here's what I'm going to do. I'm going to say, well, here's a person. I'm going to have the person start right here. Oops, right here. And this person is going to walk 6 meters to the west. So that's 1, 2, 3, 4, 5, 6 meters to the west. That's a terrible arrow I just drew. And then they're going to turn around and walk 4 meters back to the east. So they're going to go 1, 2, 3, 4 meters back to the east. So the first question, what distance did the person travel? Remember, distance is a scalar, so we simply say they walked 6 meters plus 4 meters. So the distance they traveled was 6 meters plus 4 meters. So the person walked 10 meters. Now when we're asked what the person's total displacement was, what we notice is they walked 6 meters west, and then they walked 4 meters to the east. So although they went farther west, because the east took away from it, what we find is they actually have a displacement of 2 meters to the west. Now remember, this is a vector quantity, so I must include the direction along with the actual magnitude. So let's try the next one here. A car drives 30 miles south, 50 east, 30 north, 70 west, and the whole trip takes 6 hours. I think we're going to have to look at a graph to do this, so let's get on it. Alright, so let's just have it start right here. And first we went 30 south, so I'm going to go 10, 20, 30 south. Then it went 50 to the east, so I'm going to go 10, 20, 30, 40, 50 to the east. Then we went 30 north, 10, 20, 30 north. Then we went 70 to the west, 10, 20, 30, 40, 50, 60, 70. So if you look, what we find is that the starting position was here and the ending position was here. The difference between them being 20 miles to the west. So let's go back and answer those questions. So what is the distance the car traveled? Now remember, distance is a scalar, and all we had to do is add up the values. So it went 30 miles south, then it went 50 miles east, then it went 30 miles north, then it went 70 miles west. I don't care about the directions. What I get is 180 miles is the distance that was traveled. But when asked what is the car's displacement, if you recall, when we looked at that, what we found is that the difference between the beginning point and the ending point was just 20 meters to the west. Let's take a look at that again. So you can see on this one he went 30 south, 50 east, 30 north, and then 70 west. So what really matters is here's our starting point, here's our ending point. So the displacement is a total change in position, which in this case was 10, 20 miles in a westerly direction. So our answer is going to be 20 miles west. What is the car's average speed? Now speed is a scalar quantity. To get the speed, what you do is use this equation here. The average speed is going to be the distance traveled divided by the time needed to do it. Here is the distance the car traveled. Here is the time it took to do it. So I'm simply going to say 180 miles divided by 6 hours. And that gives me 30 miles per hour is the average speed. That's a terrible MI. Okay. Now what about the car's average velocity? Now velocity is a vector quantity where we have to take into account direction. And that means instead we use this one here where delta x is the displacement that took place, and here's our displacement, 20 miles west. So we're going to say the car's average velocity is 20 miles divided by 6 hours. That's 20 miles west, I should point out. And if we say 20 divided by 6, we'll get 3.3, repeating, miles per hour west. With a vector quantity like displacement or velocity, we are required to include the direction. Alright, let's see what we got next. Okay, so in this case I want to find the magnitude of resultant vector. The bug flies 5 meters east and 8 miles north. I want to know the magnitude and direction of the displacement vector. I think we're going to have to go to the graph paper to do this. Okay, so it goes 5 east, 1, 2, 3, 4, 5 to the east, and it goes 8 to the north. 1, 2, 3, 4, 5, 6, 7, 8 meters to the north. So the resultant vector, which I'll draw in red, starts here and goes to here. So what we want to know is, when I say what is the magnitude of it, what we want to know is basically how big is this vector. So I mean, we could take a ruler and just measure directly, but the best way to do it is use the Pythagorean theorem. The Pythagorean theorem says that x squared plus y squared equals hypotenuse squared, or the x component of displacement squared plus the y component squared equals the resultant squared. So what we've got is, let's just say x squared plus y squared equals, we'll do r for meaning resultant vector squared, and therefore if we take the square root of both, that should give us the answer. So x squared is 5, so we'll say 5 squared plus 8 squared, and we'll take the square root of that, will equal r. Let's see what that equals. Well, 5 squared is 25, plus 8 squared is 64. Add those together, and what you get is what's that? That's 89. So we get 89, and what we want to know is the square root of 89 equals r, and it turns out the square root of 89 is 9.4 meters, equals the resultant's magnitude. So there's my answer right there. And if you think about it, if this one here is 8 and this one here is 5, it makes sense that this would be a little bit more than this one. 9.4 seems to be a good answer. So let's go put that in there. Now, as far as the direction, all we need to do in this class is you're either going to tell me for directions east, north, west, south, or northeast, northwest, southwest, southeast. Those are the only directions I want. We can learn later how to do angles, but we're not going to mostly worry about that. So let's go ahead and put our answer 9.4 meters in for the magnitude. Our answer was 9.4 meters, and that was to the northeast. Alright, now component vectors are basically the opposite of that, and they're really easy to do when you have a graph, which is why I gave you graph paper. So what I'm going to do is I'm going to think of this one here as being the resultant vector, and I just want to know how far did it move in the x direction and how far did we go in the y direction. So let's just use red for these. Okay, so here is the x direction, and here is the y direction. So the x direction would be, we could say it was -3 units, or we could say 3 to the west. By convention, we can use negative to mean to the west or to the left. And then, so for the other one, we have 1, 2, 3, 4, 5, 6, 7. So we have 7 to the north. If you want to think of it that way, I'll go ahead and put this one west. Those are our two component vectors that make up this resultant vector. And what we find is it's very often useful to break vectors down to their components, add those components. It's just the simplest way to solve these problems. Here we're getting towards the end of this homework. Let's see. A boat moves 30 west, then 70 north, then 10 east, then 90 south, then 60 east, and the trip takes 65 seconds. We want to know the average speed. Well, I think we need to go to the graph paper to figure this out. So let's just start here. We're going to start here. I'm going to go 30 to the west. 10, 20, 30 to the west. Then we're going to go 70 north. 1, 2, 120, 30, 40, 50, 60, 70 to the north. Then we're going to go 10 to the east. There it is. Then we're going to go 90 to the south. So 10, 20, 30, 40, 50, 60, 70, 80, 90 to the south. Then we're going to go 60 to the east. 10, 20, 30, 40, 50, 60. So here's where we started, and here is where we ended. Alright, let's try to answer the questions then that were being asked about this. Alright, number 9 asks us, what is the boat's average speed? And if we recall, the equation for speed, the average speed, is the distance, which is a scalar, divided by the time. In other words, we don't care what the direction is. We just want to know what's the total distance that boat traveled and divided by the total time it took to travel that far. So the boat's speed is going to be found by first finding the total distance. So I have to say 30 plus 70 plus 10 plus 90 plus 60 meters. All that adds up to equal 260 meters. So to find a speed, I'm going to say 260 meters, regardless of direction, divided by the time it took to do it, which was 65 seconds. So divided by 65 seconds, and that gives me 4 meters per second is the average speed. Now, what are the x and y components of the resultant vector? We're going to have to go look at that resultant vector. Let's go back to the other side. Well, you can see we started here, and we didn't. We started here. We went 30, and then we went 70, and then we went 10, and then we went 90, and then we went 60. We started here, and we ended up here. So we started in this place and ended up in that place. Let's draw our resultant vector. It's going to look something like this. There's our resultant vector. So what are the x and y components of this resultant vector? Well, the x and y components are going to be, here is my y component, and here is my x component. So it looks like my y component is going to be 20 south, and my x component is going to be, let's see what that is, that's 10, 20, there's 40 to the east. 20 south, 40 east. Let's go ahead and write that down. So the x component was 40 meters east. That's an east. And the y component was 20 meters south. What is the magnitude of the displacement vector? Well, to find the magnitude, I have to use the Pythagorean theorem. So I have to say x squared plus y squared equals resultant squared. So what I'm going to get then is, I'm going to do this down here, kind of out of the way. So what I have to do is I have to say 40 squared plus 20 squared, and if I take the square root of that, that's going to equal the square root of r squared, so that's going to equal my resultant. So let's just type that in the calculator and see what we get. So 40, well, let's just do it this way, do it all in a go. I'm going to say the square root of 40 squared plus 20 squared equals, and I get 44.7. So R equals 44.7 meters. What is the boat's average velocity? Well, so if you think about it, this is the total displacement, the magnitude of the displacement. Now I just have to divide that by the total time it took to make that displacement, 65 seconds. So my answer is going to be 44.7 meters divided by 65 seconds. And let's see what that equals. Divided by 65. Its velocity is 0.688 meters per second to the southeast. Well, I hope you enjoyed this stuff. I love this stuff. So, well, we'll check you later. Bye.